name is Emil. I'm a student here at Brigham Young University, and this is a training on chemical preparation. But first things first, we gotta suit up. So by the time you're watching this video, hopefully you know the importance of nerve growth factor, or NGF. I do have to say that this video is a simulation of how to prepare nerve growth factor, because it's expensive, there's not a lot of it, and obviously this isn't the right color of nerve growth factor. And in fact, I actually use something very familiar, and it's candy cane chocolate, so that's why we have this brown thing here. But the most important thing that you can learn from this video is something called serial dilution, and that's how we're going to prepare most of our chemicals here, because we have it in such small amounts. So let's go ahead and get started.
You can expect to start off with a small volume with a concentration of 100 micrograms per milliliter. This is because the original NGF, or nerve growth factor, as you see here, is not much to begin with. There's barely any, but we'll be putting this in solution beforehand. Hope you guys are familiar with this. For those of you who've taken some molecular lab classes, this is a micropipette. If I can focus here, this is a micropipette that can go up to 200 microliters, and it's currently set at 100 microliters. And how you suction is by pushing it until the first stop, and then releasing it. Then when we want to dispense it, we push it all the way down, past the first stop. So we start off with the first dilution of NGF by taking 100 microliters of the original concentration. So you can put it in any appropriate container, vial, test tube, etc. So our next step is we're going to be using a micropipette that can go up to 1,000 microliters. Actually, we want 900 microliters, so we'll go ahead and set that to 900 microliters. That way, when we add it to the 100 microliters of original solution, it totals it up to 1,000 microliters, or 1 milliliter. So this is how it works, same as before. We push it to the first stop to suction it up, then we press it all the way down to dispense it. We're going to take 900 microliters of buffer, in our case usually PBS, and we're going to add it to the original concentration. Intuitively, this will dilute the solution. So if you divide the original concentration by now a total of 1,000 microliters, that's the new one, you'll get a diluted concentration of 10 micrograms per milliliter. We're going to start our second set of serial dilution by taking 100 microliters of the new concentration we just made, 10 micrograms per milliliter, and we're going to put it in a new container. Then we take the same amount of buffer, 900 microliters. When we add it together, this will give us a new concentration of 1 microgram per milliliter. You guys are catching on. Same pattern here. For the third dilution, we take 100 microliters of the previous concentration and we transfer it to a new container. And lo and behold, surprise, we add 900 microliters of buffer. Then we add it together, and now it's 0.1 micrograms per milliliter. We repeat it again for the last step. We take 100 microliters, take some buffer, same thing, it didn't change, 900 microliters, add it together until finally we have the concentration we want, concentration we'll use. So 0.01 micrograms per milliliter, or 10 nanograms per milliliter.
So those are the principles of serial dilution and preparation of nerve growth factor. So we're done here. So the things that we have to do now is make sure that the lab's cleaned up, and of course we write in our lab notebooks. And as far as the vials go, we're going to be putting them back in the fridge. And so hopefully you learned a lot today, and I'll see you guys later.